Example 9.9. Suppose a baker claims that his bread height is more than 5 cm on average. Several of his customers do not believe him. To persuade his customer that he is right, the baker decided to do a hypothesis test. He baked 10 loaves of bread. So 10 is our sample size. N equals 10. The mean height of the sample loaves is 17 cm. The sample mean is given to us, so x bar is 17, and that is a sample mean. The baker knows from baking hundreds of loaves of bread that the standard deviation of the height is 0.5 cm. And that standard deviation is actually sigma equals 0.5, okay? And that is a population standard deviation because that's all the bread that he baked. So, and we know the distribution of height is normal. But sometimes it could be lower, sometimes it's higher, but on average, it should be around the average most of the time. So this is the problem that's given to us. Now, to do a hypothesis testing, the first step for us is to identify the null hypothesis H0 and the alternative hypothesis HA. And it really based on the claim, okay? You have to look at the claim, what the claim is talking about. Now the claim said the height is more than 15 cm. So, and that is the population average, okay? So that is mu right here. So this, whatever the claim is, we put it into the alternative hypothesis. Mu is greater than 15. And the null hypothesis always have an equal sign, okay? It can be less than, greater than, but it must contain an equal sign because that's the number that we're going to substitute into the formula for mu. And because we're interested in the population mean, so mu is 15. Okay, so this is very important. So for the alternative hypothesis, you can choose greater than, less than, or not equals to. But for the null hypothesis, it must include the equal sign there, okay? Because that is the value we're going to take. Now, and then the second step for hypothesis testing is we check the condition. Do we have n greater than 30, or do we have a normal distribution? Okay, we do not have n greater than 30, but we do have normal distribution based on the question. So we can continue. Otherwise, we have to resample, okay? Make the sample size bigger or find out what the distribution is. So now, when we can move on, we will make sure we pick the correct formula and calculate the test statistic. And the test statistic is a number. And in this case, because it's a normal distribution, we use the z-score. And how do we get the z-score? We look at the handout that I give you. The formula is x bar subtract mu all over sigma divided by square root of n. And that's why it's important for you to identify all these variables. So now we substitute x bar. So what x bar is a sample mean. What is a sample mean? Out of the 10 bread that he baked in this hypothesis test, that's a sample. The average is 17. Subtract what is a mu? Okay, you can find out from the null hypothesis. He claimed it to be 15 as a sample population mean. Then you divide it by sigma, which is 0.5, over square root of how big is the sample size? 11. So you enter this into your calculator, okay? Parenthesis, 17 subtract 15, close parenthesis, divided by parenthesis 0.5, divided by square root of 11, okay? Then you close parenthesis right here. You should get a number, and you have to round it. It's a z-score of 12.65. We round the 2 digits for z-score because our table, our z table, only give us 2 digits. But if you look up the row of 12, you will not see it. And the reason is because the z-score is so high. Now what it means by a high z-score, so you have to draw the picture, and that is also very important. You must draw the picture to understand what's going on. So we say the mean is 15, and we have 17 right here, and its z-score is 12.65, okay? So if you convert it to a standard normal distribution, this is 0, and that is 12.65. And this is a test statistic. You have to look at your alternative hypothesis. We're saying what's the chance that mu is greater than 15, okay? This is, and that is the chance that it happens is randomly happen, okay? And the p-value corresponds to 12.65, and it's on the right side because it's greater than, right? It tells us to take the part from the right. So it's a right tail test. This picture shows us that the p-value for z-score, that is 12.65, or p-value, you can also think of it as the area to the right of 12.65 is 0, because it's so small, okay? In that case, we know, okay, p-value is very small. What do we say? Now, if we use alpha, the question did not specify. So what is the alpha value that we usually take when it's not given? We want alpha to be 0.05 so that we can be 95% confident about our hypothesis test. So in this case, you have to refer to the handout, okay? So the p-value is 0. Alpha is 0.05, 5% chance, right? 0 is less than 5%, so p-value 0 less than alpha. We reject the null hypothesis. That doesn't mean that we accept the alternative hypothesis. That only tells us that there's enough evidence to support the alternative hypothesis. So we have, there is enough evidence to support the alternative hypothesis. And what is the alternative hypothesis? It's the claim that the bread height is more than 15 cm.